I am Shashank. Welcome to Science with Shashank. Today's episode is going to be space-time. Space-time. Space-time is nothing but space and time are interlinked. How this is possible, I am going to explain. So, let's begin. To understand space-time, you need to understand some units like absolute, relative, time, space, reference frame, etc. So let's start with time. Time is like a playing video and we are all the characters in the video. If you see, it looks like a video, but it is a continuous play of images. If many images are put in front of you continuously, are shown to you continuously, it looks like a video. For example, a flip book. All the papers in it have drawings. When flipped, they all look like video. That is time. So let's now move on to absolute. Absolute is nothing but anything which is same to anyone, anytime. Next, relative. Relative means anything which is not same, which differs from person to person. Next, reference frame. Reference frame is a place according to which you are gonna decide motion or time or space. These are the terms you are gonna need. Mainly, you gonna need a new term known as light year. Light year is not unit of time; it's unit of distance. It is defined as distance traveled by light in 1 year. It is approximately many miles in millions. So let's move on. Next, how space and time are interlinked and how gravity is related to it. So let's start. First, for example, person A and person B are friends. Both age is same. First, person A is on Earth and person B goes to Jupiter. He spends 3 years on Jupiter. When he comes back, the person A's age would be much greater than person B. Because of high gravity in Jupiter, time is very, very slow. For example, if we spend there 3 years, it would be more than 3 years on Earth. So let's move on. So this is how gravity and time are interlinked. Now space-time. Space-time is nothing but time differs from space to space. So first let us understand time is absolute or relative. Newton told that time is absolute, but Einstein proved that time is relative. How? I am going to explain you. Einstein took two clocks which were matched. Both show even nano and microseconds. One was kept on Earth and other was kept on the satellite which was roaming around the Earth. So after many days, both clocks were seen. The clock which was on the satellite was a nanosecond greater. You may think it's just a nanosecond. What does it affect? A nanosecond also affects. If the distance from Earth increases and increases, the time gonna be slower and slower. For example, you gonna take a black hole. You all know black hole. If you want a detailed explanation on black holes, let me know in the comment section below. First, black holes. Very, very high. If any satellite or any spaceship goes near the satellites or even planet, the black hole sucks the planet into it. First, assume we made a spaceship that can stay near black hole. For example, we spent 1 hour near black hole. That would be many years on Earth. Because the gravity in the black hole is very, very high. Now understand space-time relation. For example, you want to meet a person. You will tell him the place and the time, where you want to meet him and which time. So let's assume I am going to meet a person at Taj Hotel on Wednesday 7 p.m. If any of this quantity misses, for example, I want to meet him at Taj Hotel, but I will not tell when. Will he roam? Will he spend his all the day in the Taj Hotel? No. So we can't meet. Okay, let's expect I told him only the time. I want to meet you Wednesday, 7 p.m. Where would he meet me? Don't know. Will he roam whole around the world on Wednesday 7 p.m.? No. So we can't meet. So space and time are interlinked. They can't exist without each other. But Newton thought space and time are not linked. That's why any changes in space does not affect time. But it is wrong. This was proved by Einstein, and the time was relative is also proved by Einstein. Okay, thank you.